Here we are going to discuss 2023 May paper 1-2 IB Physics SL, right? First, I have to emphasize that the marking scheme is not out yet and I could be wrong in one or two places. So if you find any mistakes, please point them out. They talk about percentage uncertainty at 4 seconds, right? 4 seconds speed is 8 meters per second. Second, let's look at this error bar. The error bar goes 2 squares up. So this is 0.4, 0.4. Each box is 0.4. So this length must be 0.8 meters per second, right? So percentage uncertainty is delta V over V times 100. 0.8 is the uncertainty, 8 is the speed, times 100, 80 divided by 8, 10%, right? So this answer should be B. The car starts at rest, so speed is 0. Force is 30 Newton, but there's a friction of 10 Newton acting on the car, right? So actually there's a friction backwards 10 Newton. So we can understand net force is 30 minus 10, 20 Newton. So let's find acceleration. Acceleration is net force divided by mass, right? So 20 divided by mass here is 2. So 10 meters per square second. This is the acceleration of the car. Now this is a uniform acceleration because net force does not change. So I write V equals U plus AT for the car. The final speed is the one what we are looking for. Starting speed 0 because started at rest, starting from 0 speed, plus acceleration is 10, time they say after 2 seconds. So final speed must be 20 meters per second. So this question number 2 answer should be B. When you throw a stone upwards, it goes up and then come down. But best way is to think few things. One, when it is going upward, if you take it as positive, when it goes downwards, it is velocity must be considered negative, right? So we can see velocity must have positive and negative values. So this is definitely wrong. Velocity can't be always positive, it changes the direction. This also says velocity is always positive. That's also wrong. Now let's try to write equations. I write upwards v equals u plus at. V equals u, acceleration is, as I take upward as positive, downward is the acceleration, so should be minus, right? G times t. V equals minus gt plus u. So if I look at this equation, this is the x value, this is taken as y, so this must be minus mx plus c. We can definitely see the graph should be this y equals minus mx plus c shape graphs. We remember it has this shape, right? So I mean it can keep on going, so it should basically look like this. So the answer should be A. They talk about two situations where in one situation you just drop the ball, in another situation you fire the ball forward. I will draw in a blue color arrow. See, this one is fired. What we know is they both will have final velocity because of falling to gh. Where did I get this one from? I wrote v squared equals u squared plus 2as vertically downwards, v squared equals 0, because yes, you can say but there's a horizontal speed, that's horizontal, we are talking about vertical speed. 2gh, v equals 2gh root. So both of them have same vertical velocity 2gh square root, but there's a difference. Here he has the starting speed horizontal, it has no influence from the friction. So overall this one has bigger velocity or bigger speed. So let's check. The velocity on impact with the ground is same. No, velocity is different. Time taken hit the ground is greater. No time. If you write again one more equation, if you write let's say s equals ut plus at squared over 2, from that h equals 0 plus gt squared over 2, t equals 2h over g. It is same for both of them, height is the same. So this is also wrong because the time is same for both of them. Speed on impact with the ground is same. No, speed is different. Velocity on impact with the ground is greater for ball 2. That's right, because ball 2 has a horizontal speed, so total velocity is higher. So answer is D. We have recalled Newton's second law. F net equals delta mv over delta t. This is the background knowledge. Or delta mv, or change of momentum, is force times delta t. Or in graphical way, I can say, if you see force on the y-axis and time on the x-axis, if you see a graph and the area under this graph represents the change of momentum, right? This is change of momentum. So let's find this area for our the given graph. This is F max. So area equals, or change of momentum equals, F max times t divided by 2. But this is not what they asked. They asked final velocity. So mv minus m times 0. Why? It started from rest. Okay. So starting momentum is 0. F max times t divided by 2, m times v, F max times t over 2. So v equals F max times t over 2m. Answer should be A. Let's try to remember what we know about friction. If there's an object on a horizontal surface, if you create a pulling force, there will be a friction opposite to the motion, right? And until at least the motion starts, the friction is proportional to the pulling force. So we can write friction is proportional to the pulling force P, right? Now let's look at our situation. This situation, there are three forces acting on this object. At the center of gravity, the weight of the object happens downwards, and there's a contact force and friction. The weight of the object I am going to break into two parts, or resolve into two components. One is parallel, one is perpendicular to the surface, right? So here, if this is theta, this is theta, so this part will be mg cosine theta. The one parallel to the inclined plane will be mg sine theta. From here, for this situation, we can write friction force is proportional to mg sine theta, right? But m and g are constants, so I can change this concept into friction force is proportional to sine theta, right? Answer is D. Here again we need to understand a basic concept. What is power? Power is how much work is done in how much time, right? Time is no problem here. This is 2 seconds. The problem is how much work is done. Work is done in two different ways. One, to store gravitational potential energy. Second one is to create kinetic energy. So first situation, I want to know how much height the object has risen within 2 seconds. So I write S equals U plus V over 2 times T. From there, H equals 0 plus, ultimately it is 4, in divided by 2 times time is 2. From there, I can see the height the object rises is 4 meters. Now mgh in this example is m. G is, let's take it as 10, 4. So 40m, right? Half mv squared is half m. Final speed is 4 squared 8m. So total work is 40m plus 8m, 48m, right? So power equals 48m divided by 2. What does this mean is total work divided by total time, right? In this case, you get 24m. For question number 7, answer should be B. Again, this is also conservation of energy concept. Here we have gravitational potential energy because speed is 0, no kinetic energy. Here it converts into kinetic energy, but not all of it, or only 80% of gravitational potential energy changes into kinetic energy. mg h is 10 times 80% equals half mv squared. Let's look at m cancels. So from there v squared equals 2 20 times 80% times g, right? V equals 16 square root g. From there you can get 4 square root g. So answer should be C. The temperature changes from 100 to 330 Kelvin. They ask what's the change in temperature in Celsius. Let's take a small example. Let's think you change temperature from 27 Celsius to 37 Celsius, right? So change of temperature is 37 minus 27, 10 Celsius. But let's think about the same situation in Kelvin temperature. So in this case, how to convert Celsius to Kelvin? 273 plus theta is T, right? So this temperature is 300 Kelvin changes to 310 Kelvin. Do the calculation. You will understand this is 310 Kelvin and this is 300 Kelvin. So here also change of temperature in Kelvin, 310 minus 300 is still 10 Kelvin. What can we learn from this situation? We can understand change of temperature is the same either in Celsius or Kelvin. So 300 change of temperature is 330 K minus 100 K Kelvin. So it gets in you 230 K, right? Or you can say so change of temperature is 230 Celsius. I repeat, I don't mean temperature is the same. I mean change of temperature is the same in Celsius as well as Kelvin. So answer should be, hold on, change in temperature final minus initial. So it is positive value. So answer should be B. What is internal energy? General definition is total of molecular kinetic energy and molecular potential energy. But the interesting about ideal gas is this is an intermolecular bond. For ideal gas, there are no intermolecular forces, so this does not exist. So molecular potential energy does not exist. So internal energy is only about 3 over 2 knt. This is about number of molecules and this is Kelvin temperature, right? So only two things can affect internal energy of an ideal gas: number of molecules and temperature. So if you look at sum of intermolecular potential energies of the molecules, internal energy has there are no molecular potential energies in an ideal gas. Energy required to change is no. The sum of molecular kinetic energy of molecules. Exactly what I mean is internal energy is actually uh, molecular kinetic energy of one gas molecule times number of molecules, and so answer should be C. Number of molecules is number of moles times Avogadro number, but number of moles is mass divided by molecular mass, right? So number of molecules is number mass divided by molecular mass times Avogadro number. So for helium in this example, number of atoms is mass is x, molecular mass is 4, Avogadro number first equation. For oxygen, number of uh, molecules is 2x, mass is twice 32 times Na, right? This is the second equation. So 1 over 2 number of atoms in helium 2, number of molecules of oxygen, we get xNa divided by 4. This goes up, and 2xNa. If I look at the numbers, this cancels this one. This is 4 times 8. 4. Answer should be 4 to 1. Answer should be C. Okay, the two situations. Uh, First situation, I write PV equals nRT for first situation. So pressure is P V N, 10 divided by molecular mass R times T, right? First situation. Second situation, pressure is 3 times. Second situation, pressure is 3 times 2V equals 10 plus mass is M, capital M R times T. Temperature has not changed. If I do this calculation, 2 over 1, I will get 6 equals 10 plus M divided by 10, right? From there I can get additional mass is 50 milligram. Answer should be C. Question number 13 is about simple harmonic motion. We have to understand the extreme points are where the acceleration is maximum and displacement is maximum and velocity is 0. In this example, if you take right hand direction as positive, so on the leftmost point, amplitude is minus, acceleration is towards the equilibrium point, so it is positive. So this is velocity 0. Velocity is 0 point, and the displacement must be negative because displacement is measured into positive direction from equilibrium point. Here it is into negative direction. So answer should be B. So obviously if she hears a loud sound, she is moving an antinode to antinode. And we know the distance between antinode to antinode distance is half wavelength. So half wavelength is given to be as 1.5 meters. Wavelength of this wave must be 3 meters. That's first understanding. Second one, they ask frequency. Frequency is V over lambda. V is 300 meters per second. Wavelength is 3 meters. So this should be 100 hertz. Answer for question number 14 should be C. So this pattern is called first harmonic. Then you may develop this pattern. Then there's another pattern which could be produced like this. Now about their frequencies, if you take this one as f naught, this should be 3f naught, this should be 5f naught, because one side closed tubes can only produce odd harmonics. So in this case, but they have given you this 3f naught is 150. So obviously f naught should be 50 hertz. So if you look at this pattern, all the frequencies which can be produced is 50 hertz, 150 hertz, 5f naught means 250, 350, 450, these numbers. Now if you look at this one, out of these numbers we derive 50 is given, so answer should be B. Let's see. Let's just imagine there are two molecules which are very close to point A, and as this side is taken as positive, it means to the right hand side, it means this molecule on the left hand side of A has moved to the right. Similarly, this side, the molecule has moved to the left. So if these three molecules have been pushed closer to each other, what do you call this space? This is a compression, right? Similarly, if you check this one has moved to the left, this one has moved to the right. So this is a rarefaction. This is a normal pressure point. So we are looking for a compression, so answer should be A. Question number 17, easy way is let assume small internal resistance is 2 ohm, external resistance is 3 ohm. So current is EMF divided by R plus R. So 10 divided by 2 plus 3, you get 2 ampere, right? Now new situation, internal resistance is still 2, external resistance is doubled, so 6 ohm. So I dash equals E divided by R plus R, 10 divided by 2 plus 6, you will end up 1.25 ampere, right? Now if you compare this previous current to now new current is less but not as less as half. So I dash is more than half of I. So answer should be how much voltage is given to the external resistor in this example depends on how big this resistance is. Example VR divided by V small r is R to R ratio. Now R has increased and this one does not change, so obviously this also has to increase, so by decreasing this one and increasing this one, so VR has increased. So answer should be A. Background knowledge is parallel circuits are the components of parallel circuits are independent of each other. What I mean is, example, let's say there's 2 ampere current. If you close this circuit, this also, as this resistance and this resistance are identical, this also will get 2 ampere current. These are independent entities. So based on that, as current is A, V, N, E, current is the same material, charge of an electron does not change, identical wires, so drift speed also has to be the same. Answer is B. First thing is that this Q charge will push this positive 1 coulomb charge away. This positive Q coulomb charge also will push this one away, but not as strong. Why? Because electric field strength is KQ over R squared. In this example, this distance is further, the hypotenuse, so the force is smaller. Now this negative Q charge will pull it closer, right? So there are three forces. The smaller repulsive force I can break into two parts. So if I add all the forces, I can see left side there will be a resultant force smaller. In vertical direction there will be bigger force by adding these two components. So these are the two components of forces acting. The resultant force will lean towards the vertical direction because vertical force is bigger. Resultant force. So overall the force should be into, let me check here and here. Yes, answer should be B. Let's think there's a current I passing through resistor X whose resistance is R. This is about Kirchhoff's second law. I will write total EMF equals total IR for whom? For A, B, C, D, A loop. Okay. Now when I look at this cell on the left hand side, you are going from positive to negative, so this should be negative. So negative E, over here it is positive because you are going from negative to positive. 2 epsilon equals, there's only one resistor in that loop, you can say, but there's another one. This is not important because we are focusing on the outer loop. So the current is I times resistance is R. So current through X should be epsilon over R. Answer should be C. As background knowledge, we need to remember Fleming's left hand rule. We know if you keep middle finger, point finger and thumb finger of your left hand perpendicular to each other and point middle finger into the current direction, point finger into the magnetic field strength direction, thumb finger will give you the direction of the force, right? Second thing we need to understand is, as this is a negatively charged object, as it is moving downwards, so the current is opposite to the motion of a negative charge particle, so current is upwards. The magnetic field is always from north to south, right? Now let's use our left hand. Magnetic field from the point finger and current is from the middle finger. If you do this right, you will get there is a force, but that force is into the face. So answer is D. We need this knowledge about electric field. Work done in an electric field depends on potential difference and charge, right? Now let's write a conservation of energy equation. V times E. Why E? Because charge of an electron is E, is half mv squared. V stand for, don't get confused, this is the speed and this is potential difference. Two concepts. So from there, V squared equals 2VE over M. So final speed is 2VE over M square root. Answer should be A. To do question number 23, we need to remember one thing. Angular velocity is angle divided by time. Similarly, if you are moving in a circular path, the centripetal force is given by mr omega squared, mv squared over r, or mv omega. All three equations are the same, just in three different forms. Okay. So let's go back to first equation. First situation, angular velocity is theta over 2. Second situation, angular velocity is 2 theta at the same time, so it is twice. Remember that one. So now T equals m r1 omega squared for the first situation. For the second situation now is also tension is the same, m r2 omega has become twice, right? This is the second situation. Now let's use this one. So m r1 omega squared, m r2, 2 omega squared means 4 omega squared. I can cancel m and omega squared can be cancelled. So r1 equals 4r2. So r2 equals r1 over 4. Answer should be A. Again, we need some background knowledge. Here, alpha particle symbol is, alpha particle has 2 protons, 2 neutrons, so mass number is 4, atomic number is 2, right? Now let's write the equation. Platinum 175, 78 changes into osmium and an alpha particle. Here it is 4 and 2. So if this is 175, this side has 4, 171, 78, there's 2, so 76. Protons in this case is 76 for osmium. Neutrons is 171 minus 76, you will get 95. So number of neutrons should be 95, protons should be 76, so answer should be D. To do question number 25, we need to remind ourselves what is the definition of energy density. Energy density is the energy produced divided by volume of the fuel. Now this car outputs 20 kilowatt power, but actually we have to power out is 20, so power given by the fuel is twice of this because it's only 50% efficient, 40 kilowatt, right? Now if you think about 1 second, so energy density is how much energy produced in 1 second, 40 times 10 to the power of 3. And how much volume is used? 1 times 10 to the power of minus 5. So this becomes 4 times 10 to the power of 4 divided by 1 times 10 to the power of minus 5, 4 times 10 to the power of 9, right? This 10 to the power of 9 can be written as giga, right? So 4 giga joule per cubic meter. This is the answer we are looking for. 4 gigajoule. Yes, answer is D. Let's think about answer D. Answer D says gravitational field strength taking 9.81 as an approximation. Is it true? Actually, gravitational field strength, how it changes with the distance from the center of the earth, the graph looks like This is inversely proportional to distance. So only here on the surface this is 9.81, inside less than 9.81, outside less than 9.81. So what does this means is, we can use gravitational field strength G equals 9.81 ms minus 2 only on the surface, or maybe you go from point A to point B as long as R plus H is same as R. What it means is, you don't go far from the surface, either upwards or downwards, then only you can use G equals 9.81. So this is actually an approximation. This is not exactly always 9.81. If you go further, it will decrease. If you go inwards to the towards the center of the earth, it will decrease. So answer is D. Question number 27 is about rate of decay, but we have to think about, there's a background count rate as 30. So from the source, the real count rate is here 120, changes into 90 minus 30, 60. So we can see in time equals 20 seconds, right? So 120 has changed into 60 in how much time? 20 seconds. This is half-life, right? And then it means this will change into 30, this will change into 15, always 20 seconds, another 20 seconds, and now 15 becquerel or 15 per second. Actually the reading you will get is, the background radiation is always there, right? So at this point you will get 45 BQ or 45 per second. So it needs 3 half-lives to get into 45 becquerel. So the answer should be C. If you look at this equation, we should know this one is a pion or it's a meson. Whatever the quark composition, we know it is like, let's say, up and anti-strange. It is made of a quark, any quark is okay, and anti-quark. Very importantly, this is baryon number of a meson is 0. So how to use this one? This baryon number is 1 plus 1 on the left hand side. But right hand side, this is not a baryon number, is 0. So baryon number is 1. So baryon number is not balanced. So answer is A. This is the violated rule. Charge. Charge is, proton is plus 1, neutron is 0, right hand side is also plus 1, because meson does not have a charge, so this is not violated. Lepton number, there are no lepton. Strangeness, we don't even know the quark composition of a meson, so we can't predict that, but we definitely know the baryon number is violated. In the data booklet, this on topic number 8, the power of a wind turbine is given half a rho v to the power of 3. Sorry, this v stand for the speed of wind, and this is area of the windmill, and this is density, this is the power output. But actually, area of a circle, this windmill sweeps a surface area of a circle, so I can write pi r squared. And but we have to, in this situation, we have to multiply the value by efficiency, because this is power output, not input. So in this case, for x, we can write power of x is half rho pi r squared v3, and efficiency is eta. This is the first one. For y, power of y is half rho pi. The radius is 3 times, right? So 3 r squared v to the power of 3. Efficiency is also twice. If you look at this one, 3 to the 3 squared. So you can see this is 18 times px is py. So py over px, they ask, must be 18. Answer should be D. First background information we need is, what is albedo? Albedo is reflected to total intensity ratio on a surface. So if you get 100 watt per square meter, albedo is 0.3, it means 30 watt will go there and 70 watt per square meter will get into the interior of the earth, right? There's another problem for the earth, that is the transmitted intensity also will be transmitted back from the atmosphere, 60 watt per square meter. Now you have 70 watt per square meter intensity and 60 watt per square meter. If the earth does not want to get warmer, earth has to make sure this 130 per square meter watt per square meter should be transmitted. If it transmits less than that, it will be warmer. If it transmits more than this, it will get cooler. So answer for question number 30 is D. These are my answers. I'll really appreciate if you hit like button and subscribe to my channel, because I'll be uploading more videos soon. Thank you very much.